Hello everyone. My name is Dipanshu, and today I have come up with a new video which will be based on the Kubernetes forensics, complete threat hunting practical lab for threat hunters. Actually, the day which when I published the Docker forensics lab, which I got a lot of love from you guys. I got a lot of messages post that create something on Kubernetes forensics as well, because in the today's mindset, the Kubernetes is one of the most complex architecture in the world, but it's not actually, because Kubernetes, when you are implementing Kubernetes in the beginning, you might face some issues, but once you are familiar with all the Kubernetes concepts, you know how to set up the Kubernetes environment, how to set up the clusters in this, how to create the clusters, how to create the different clusters, how to set up your pods, how to set up your containers inside those pods, and so on. Once you understand how to configure the web services into that, once you understand all the concepts in Kubernetes, Kubernetes is one of the most beautiful architecture in today's world. But in the recent studies, it is being seen that when we are hosting the web applications, due to the uh, uh, issues in the web applications, you know, the in the from the front side, the attackers, when they compromise the Kubernetes clusters, you know, they are able to perform sort of a lot of attacks in this. So for an example, a Docker, they might land on a Docker enabled VM, and then they perform the Docker in Docker attack, and they are able to take the root of the complete clusters. Okay, post that. Okay, so similar kind of environment I have set up in today's lab. I am also thinking to start with my red team lab on Kubernetes. You know, because my area was always from the offensive. I always like offensive things to do, but you know, from past so many years now, I'm doing forensics, threat hunting, cyber threat intelligence, incident response, so my actual goal has been shifted from offensive to defensive side, but I always love to perform offensive side. So that is why in my videos as well, you always see the offensive stuff. I go from like complete scratch to complete pro threat hunting in the real like environments. Okay, so in this video, what we will look for the basics of Kubernetes, but the focus will only be from the threat hunting or forensics perspective, just the very basic definitions. This video, I will let me first tell you guys that this video is not for those who only know the very basics of Kubernetes. This is for those who have the experience in Kubernetes clusters, Kubernetes architectures, Kubernetes, architecture, which explains the difference between the master and the worker nodes. How to set up the pods in your clusters, and so on. So this is not for the newbies who are there in the Kubernetes or in the cloud native security. At least you should have spent at least 1 to 2 years in setting up the Kubernetes clusters. Only then you will be able to understand each and everything in this video tutorial, but I will try to keep the things as simple as possible, like in my other videos, so that whosoever is starting their career in threat hunting, they will also be able to understand the forensics, how to perform the forensics in the Kubernetes clusters. Okay, so in this video, we will look for the basics of Kubernetes, but the focus will be completely from the threat hunting or forensics perspective. Then we will set up the complete end-to-end attackers compromise lab, which will include the following: reverse shell to attackers machine. So, for an example, the attacker has already compromised the Kubernetes cluster. In my red team series, we will look for how we will compromise the Kubernetes cluster. But in this lab, consider this scenario that the attacker has already compromised the cluster. Now it has already taken a reverse shell to the attacker's machine, means from the compromised lab to the attacker's own machine, and he has already created a persistence using cron job. Then the attacker is performing the secrets exfiltration, so we will look for that. Then it will include the lateral movement in the cluster. Then I have created a bonus lab, just This particular lab was already created like many weeks back, but but I didn't get a time to record the video. So what I was thinking, to record a video yesterday night, but what happened was, due to some incidents, I didn't get some time. So I created a small bonus lab, which will be a token stealer lab, in which the token will be set up, between the victim to the attacker machine, and the attacker is trying to steal, the victim and the some applications which are running in the Kubernetes cluster, whether it is the same Kubernetes cluster or it is in the different Kubernetes cluster, maybe in the different VPC or maybe in the different VNet if you're using Azure. So there are API services that are being running in between, and we will try, and that hacker is trying to steal the token. So we will see, the from the logs how we can retrieve that. Then we will perform the threat hunting like a real environment, like a pro forensics analyst. We will look for all the steps, and also I have written a complete automated shell script which will perform the forensics for you. I will upload all this material to my GitHub, and I will expect everyone to to contribute to my that particular Kubernetes lab, because it will give me visibility as well. When the external contributors they come and start contributing to the open source projects. So the license will be completely MIT. You can go ahead and modify and practice in your own lab environments. Plus the I have also in the community we have also we were also discussing these things, that whether to showcase these things on the cloud itself directly by setting up the Kubernetes cluster. But many of those who who cannot afford to to set up everything on cloud, who don't want to pay, this lab will also help you to understand all the concepts locally on your own machine. So I have set up this machine on the Kali as usual. You can set up this machine on Ubuntu, or maybe you can use Parrot, or you can use any other Debian based system, or the or others or other Linux systems such as Fedora, CentOS, and all those operating systems. So without wasting more time, we will go ahead. But before that, why Kubernetes forensics? In past few years, we have seen huge attacks on the Kubernetes clusters, basically due to uh, the the issues in the web applications or the front end applications, maybe via the mobile applications or API services or something else. The attackers, once they land onto the some containers which is running inside a pod, they are able to compromise the full Kubernetes cluster. Okay, uh, there is a very good Kubernetes pen test module, which is Kubernetes Go. You can go and check that if you want to do the pen testing on Kubernetes Go. It is very beautiful, and you can add your own attacks as well. It is very beautiful. It will cover the maximum concepts from the pen testing of Kubernetes clusters. Okay, so you can go and have a look at that. So why Kubernetes forensics? Because certain attacks have been seen recently. For example, CVE 2018 1002105, which is the Kubernetes API server privilege escalation, in which in 2018 we saw a critical flaw allowed the unauthenticated attackers to compromise the Kubernetes nodes via the API servers, essentially granting the root access cluster-wide. Then another CVE which was published in 2020, which is CVE 2020-8554, which is nothing but the MITM via load balancers or external IPs, in which the attacker, enabled to redirect the whole traffic inside the clusters, making Kubernetes behave like their own internal MITM device. Okay. Then very critical CVE, which we saw in 2021, which I also checked in the environment where we were performing certain activity. We were able to also compromise this via the Kubernetes cluster via CVE 2021-257441, which is nothing but the node proxy path travel, in which an API was being misused to let the attackers read the sensitive files directly from the nodes. So this is very critical to understand. that the attackers actually didn't compromise the whole Kubernetes cluster, but what they did, they they used the API which was connecting to the Kubernetes cluster, and then they read the whole sensitive files directly from the nodes. Okay, and that doesn't hold them back to one node, but actually to all the nodes in the widely in the Kubernetes cluster. Okay, then a very famous 2018 Tesla Kubernetes breach, which is open in the market. Attackers mined the cryptocurrency in the Kubernetes cluster after accessing an exposed dashboard with zero authentication. So that was kind of misconfiguration in the Kubernetes cluster. Basically, so the attackers, they just utilize that and compromise the whole Kubernetes cluster in the Tesla. And then SysDig report, which was published in 2023, which includes the studies on crypto miners, reverse shells, and rootkits. Okay. So now we will go to our lab basically. So just before that lab, I just want to clarify certain concepts, just basics, very very basics that will be only for the only from the threat hunting perspective. So Kubernetes, also known as K8s, is an open source container or orchestration platform which will help you to automate the deployment, scaling, management of the containerized applications such as Dockers. Okay. Now, what it includes, the core concepts. So we have a master node and we have a worker node. Basically, the master node is being used to deploy each and everything in the worker nodes. And the master node is just to so from very, not going into much deep. So the master node is just to provide the instructions to the worker node. Everything what the master node says, the worker node, runs it. Okay. And what this nodes usually contains, the pod, which is the smallest unit in Kubernetes, which will contain your actual containers on which the operating systems or the storages or databases also or any other services run. So what is a node? A node is nothing but a worker machine where the pods are being scheduled. So what is deployment? How deployment defines as how we deploy the pods and ensure a specific number are running. For example, with this command, we are deploying the Nginx web server. So what is a service? Service is nothing but a set of instructions which are being exposes the pods as a network services. Okay. Namespace, as the name suggests, that it is to logically partition of cluster to isolate the resources from one to each other. Okay. Then config map and secret. Config map that stores the non-sensitive configuration, and secret that stores the sensitive data. Service accounts used by pods to interact with the Kubernetes API. Volume used for persistent storage. RBAC, which is a role-based access control. And I have given certain useful commands and just very security tips for the beginners. I don't know who all will be watching my video, but if you are very beginner, uh, this is just a security tip for the beginners, not everything. Very starting point. Okay. So now we will quickly switch back to our threat hunting lab. So don't worry. I will upload all these notes and everything to my GitHub repo. You can download it from there. So as said, this is my complete Kubernetes lab. So before going to this, let me just quickly run through the YAML files. So we will use the kind, to deploy our Kubernetes cluster. So the YAML file for kind includes the cluster basically, and the name will be attacker lab. The role will be control plane. So my control plane will be set up from here. And what will be the port mappings? It will run the container on the 30,000 port number and the host port on 30,000. So let's get the first the reverse shell, because in order if we see it will be reverse shell. So if you say the name is being set up, so the kind is will set up the pod, the name will set up as reverse shell, host network true, containers with the name attacker, the image will be Debian, and these will be the commands that will run bin slash bash -c apt update. It will install the netcat on the machine. Once it installs the netcat, it will take the reverse shell on my attacker's machine. Let me show. This is my machine. You can use the other machine as well, and you can run the netcat on other machine as well, but this is just for demo lab. So I am taking the reverse shell on the same lab itself, but you can take it on another lab as well. I have tried it. You can try it as well. In my red team series, which I am planning to start, I will use the multi operating systems to perform the red teams and other stuff. But anyways, then it will do the persistence. So this is the cron job that is running, okay, and the name will be backdoor shell, and the command that will run bin slash sh to open the shell. Then it will echo running backdoor job sleep 30. Okay. Then after persistence, it will do the lateral movement. It will first take the secret. It will look for the secrets if there is any secrets on the configured machine or the configured victim machine, which will contains the password as base64 this, and the key will be the password and the name will be dp secret. We will extract all this information from there. Then it will do the lateral movement. So lateral movement, it will download an script which will be executed directly from the temp directory using the sh command, and the restart policy will always be never. Okay, and in the end, the my particular bonus lab, which will be token stealer lab, where it will steal the token by installing the curl and JQ. Then it will cat var run secrets Kubernetes IO service account token, and then it will post all the token on the reverse shell that will be taken on the attacker's machine, means on this machine only. So I will tell you how. Okay, using the code 8080. Okay, so without wasting any time, so deploying the let's start deploying the lab. So the very first command I want to run, sudo kind create cluster --config kind config.yaml. Let me enter the password. So it will take 2 to 3 minutes to deploy all the all the labs, all the complete cluster basically. So just give it a few minutes. Now I will not pause or anything in between in this particular video, so that you should get a real look how much time it usually takes, to deploy the labs. Just give it a few minutes. So it has ensured that the whole image is completely fine. Now it is preparing notes. Now it is writing all the configurations that we have given it in the kind config.yaml file. Now it is starting the control plane. This is what I like about kind. You can use some other Kubernetes tools as well, but I personally like kind, so I develop everything on kind. But in the red team scenario, I might use Kubedian or kind, which I have not yet decided, but something like that I will use. Then to check, we can run sudo kubectl cluster info, to check if everything in the cluster is fine. Minus context kind attacker lab, which is our attacker lab. Okay, so everything is working fine. You can see that our attacker lab is working on this particular URL. Sorry, this particular URL. Let's just dump the cluster info once. Oops, sorry, dump. So if you want to see what happened at the backend while it was setting up your Kubernetes, you can go through the whole, dump file. But I will not go through this because this is not the, Kubernetes class. So if you are very newbie, I would suggest that you should learn about Kubernetes each and everything. But you know, so if you want to delete, the delete command will be delete clusters all. Now let's deploy our, I will not open any other terminal. Let me just split view at the bottom, or let's open two tabs. That is more convenient. Okay. CD, I think it's in downloads. Yep. So let me just kubectl cluster information minus minus. It is running fine or not. Let me just, yep, it is running everything fine. Let me just make one more. Uh, let's very first take the reverse shell. Let me just do it. So sudo netcat minus lvt. My first lab will be on port 4444. Now, if that is an attacker machine, he will not use multiple ports, but to make everyone understand the concept, I have used different ports. One lab is on 4444, one lab is on 8080, just to showcase the difference. So let me just deploy this lab, kubectl apply -f reverse shell dot yaml. So now it says pod reverse shell created. So let's see kubectl pods. Sorry. Let's see if we get a reverse shell. Yes, we got a reverse shell over here. We see who am I. This. Okay, I run an ls. I go to home. So I am in the root directory basically. I can go to anywhere, we want to. We can create, anything, but I will leave this particular reverse shell over here. This will come in another, in another few minutes. We will come to this. Let's open another reverse shell on 8080 port. Sorry, on port 8080. And let's deploy the file, which is the next is your token stealer, sudo kubectl apply token stealer. So it says the pod is created. Let's see. Just give it a second. Pod is created. Yep. It because it is reading the API, it will take a few seconds. I think in the last lab, when I was testing this lab, it doesn't take that much time, but I think it is reading the APIs in between. That is why it took some time. We will copy this token somewhere, maybe. So sudo. I will open nano. Let's open nano token.txt. So let's paste this token. Control. We will use this token in the in while we will utilize this token when we will be performing the attack. So let's now deploy the lateral movement lab. Sudo kubectl apply -f, or let's perform the, or let's any lab you can do. So lateral movement lab created. Now let's do it for the persistence. On job created, and let's now, for the secrets. Okay, secret DB created and pod we can create it. Okay. So now we will start with the threat hunting. Let's suppose the constraint here is that you have already taken the snapshot of the compromised machine. So let's suppose this is running inside a VM or it is running inside a cloud. You have taken the snapshot and the logs from the Kubernetes cluster. Now what you will be doing, you will be deploying that particular logs, or you will be refining those logs, or you will be getting a snapshot from the particular cluster. So how to perform the threat hunting now? So we will perform the threat hunting on the same machine. The only thing over here is that you just take a snapshot and you have opened up the shell over here, and using that particular shell, now you are performing the threat hunting. So the very first command that I want to run on this, that what pods were running when we got the machine. So one pod that we were getting is backdoor shell, lateral movement, reverse shell, token stealer, and app. Don't worry about this because these are already completed, and lateral movement I switched it off for certain reason. But the performance or the activity has already been performed. So that is why it is showcasing this. Now, if we want to run, the, sorry, oh, wide. So it will give us the complete information about the, let me just smaller this sign so that everybody understands, and clear this screen, run it again. So it is running in the namespace default. So we all knows that default namespace, if we don't provide any namespace, it will run under the default namespace. Then it is running with the backdoor this. Ready status completed means the activity what was there, it is already completed. This is the IP of the particular pod under which this particular the information is running. Then we have lateral movement, reverse shell, token, and some other pods which are running on this. Let me just clear the screen. Let's set what nodes it is running on. So it is running on attacker lab control plane, which is in the ready state, which we already know that the node is already created. So it means on this particular Kubernetes cluster, there is no worker node that is being added. But when you get a real environment, you will see n number of worker nodes that are being added to it. Okay. Let's go back to the pod. So let's take this example that I want to know what is running inside this particular pod. Okay. So let's understand this with the describe command. I think this is the command only. Let's understand what is there in this. Let's use the mode. Okay. It doesn't have a resource type. Oh, sorry. I think the command is short. Yeah. So let me just write a mode. So the name of the particular pod is backdoor shell, namespace default, service account default, node name on which it is running is attacker lab. It was ran on today's 14th June. No, I think the name is very wrong. I think So what labels it is running? It is running as a batch Kubernetes or tile. So in Kubernetes, the tags and the labels they go by this. The type of the activity that is being performed by the particular pod is being tagged as a type of activity inside the pod. Okay. Then we don't the attacker didn't set any annotations. The status was succeeded. The IP is 10.244.0.8. And it is controlled by a job that ran with the name, backdoor shell, and the ID number that is being given to this. This is the containerized ID, very very critical. The image under which it was ran, the image ID under it was ran. You know. So what are the commands? Commands were this. So let me just look into this. The command ran was bin/sh echo running backdoor sleep 30. Okay, but it didn't provide the actual command inside the container. Okay, so now we will look for what exactly being ran inside the in the Kubernetes cluster. So let's look for the services. So the Kubernetes cluster, it is running on 10.96.0.1. It was running on, and it was using the uh, port 443. So on the default, the Kubernetes is running on this, but on the kube system namespace, the cluster IP is this, and it is exposing services DNS and something I don't know, but is running on 9.153. Then let's look for the endpoints. So we have the multiple endpoints that are being deployed on this particular Kubernetes cluster. Let's look for the privileged pods which are being deployed by the attacker uh, and the administrators. Let me just you can just look for the privilege pods. Sorry, dot maybe JSON. That is the best way. Sudo sublime. I don't know if sublime is there. Yes, sublime is there. Well, this is vanilla machine, so I don't know. So let's look for the privileged pods that reign. So privileged pods means not with the normal user permission, but something with some sudo or maybe something with the root privileges or administrator privileges or controller administrator or worker administrator. So just to understand with what privileges it is running there. Okay. So the very first uh, uh, pod is the backdoor shell. Another, and we have echo running backdoor job. I think this is for the persistence. Then cluster first, Cube API success, uh, then busybox something to extract out the secrets. Then another backdoor shell with UID this, and the source version is this. Echo running backdoor job this, and these are the IP addresses. The cluster IP is basically this is the host IP on which the cluster is running. This is the pod IP on which is running on the node, and yep, here it is block owner deletion true and controller true. So this looks very suspicious. Remember that, and it is running with the job batch.kubernetes.io, and this is the controller UID, and the job name that ran was this. Uh, the logs for the termination are being stored here, so we can dump this. Now the attacker was trying to read the something from service account. Okay, it is running on the node name attacker lab, which is correct. Operator exists. Here it is trying to read something with tokens. Okay, here it is something very nice. It is trying to download some evil.sh on the temp directory as expected, and then it is trying to mount. It is trying to read the mount path from there, and again something. Here it is trying to install the netcat to take the reverse shell. Do we have the reverse shell in this word? Yep. Here is the reverse shell he's trying to take. Here it is running some commands to read the secrets uh, or to dump the token at here on this particular attacker's IP address server onto attacker server basically. And here is the command basically. Um, Here's something, um, some DB password it is trying to steal something secrets or something it is trying to steal. Um, key code 88P is running for fail DNS. For DNS. I think that's all we have as of now. Ah, just the while setting up the user which who was setting up the uh, particular Kubernetes cluster, you can see where the service account is stored, what secure code it has taken, where your signing key was being stored, where is your API key which was being stored, and where is its certificate. So all locations. Where is the PKI cluster will be there. This is for the complete PKI cluster storage from where the Kubernetes is running. And same goes for the controller manager. And it's something more interesting. So why we are doing this? So that when you are creating report and you want to submit it in to the organization or maybe in the court, you should have all this information writing there because the timestamps along with the information as deep as possible is required in the forensics. Okay, something more critical. No. So this was all. So now we got the IP addresses on which the everything is running, some commands and something, which is very, because this is a JSON format, where, very difficult to understand. So next we will try to understand, the pods which are using the network. So kubectl get pods -a JSON pod which will try to get the network name. Okay, so let's run it. So these are the the pods which are using the network as of now. So let's look for the pods which are using your cron jobs. So let's look for get cron jobs. Just to check if there is any persistence which is being created by the attacker. So yes, there is a cron job that is running with the name backdoor shell, which is very suspicious. So let's look what is running inside this. kubectl describe cron job. I think this is the command. I think that I correct. Backdoor shell. Yes. So let's see what is there in the cron job. So backdoor shell, which is being scheduled after every 2 seconds. I think this is the correct format for this. Concurrency policy allow, so that if the cron job stops, the it should automatically be on again. Suspend, no, it should never suspend as it is an attacker. Now I have kept it for you know for a reason, so that when you are checking for the job history, you should check if the job history is being set up, because let's suppose after this cron job there is another cron job that has to be submitted, but that is in a hidden mode. Okay, so that you will be able to understand if there is a job history enabled. Okay, any job history failed only one time, any deadline seconds, nothing. So what is the command? bin/sh echo running backdoor job sleep 30. Okay. Last schedule time when it was ran on Saturday 14th June 2025. I don't know why it is showing the wrong map. Maybe my colleague set up it with that. So which is running. So all the cron jobs were successfully created and deleted as expected, because this is created by the attacker. So attacker has done that, but if you start reverse engineering it, you will be able to get each and everything. So created backdoor. Okay, so completed job. Okay, successful create, completed, successful create, completed, create, and now the deletion starts. So this is very critical, very critical to know at what time it ran, what time it completed, and what time it got deleted. That is very critical. Okay. Now let's try to utilize if some secrets were being used here. So we will use the secrets command. Yes, we have the secrets with the name db secret. So let's describe that. The name is db secret. So it is giving the namespace, it is storing it in the default. The type is opaque and the password is of 11 bytes. Okay, let's try to uh, decode what is there. Get, I think this is the command db secret minus 4 json path equal to 2 data. I have not written it in my notes, but if I am correct, this should give us some base 64. Yes, it has given the base 64, and let me decode it completely. When I will be publishing this in GitHub, I will add this command. So yes, it has successfully decrypted the base 64 and it has given us the super secret. Okay. Let me do one thing. QCBO get pods. Oops. Get pods. there is a victim app also running. So let's describe what is uh, describe victim doesn't have a resource. Sorry, the command is this. So describe victim app. So yes, so when we were looking for this, the DB password is stored, set key password in secret, DB secret, and nothing much. So we can pull it out. Let's check the token abuse. So sudo kubectl get cluster role binding. Let me just small this and now again run. So we have these all roles in the cluster role binding. Let's grep it with the admin if we want to see the roles first. So if I want to know what roles I have been, what roles I have identified on this. So get cluster role binding, grep admin. So we have two admins, which is cluster admin, and we have kubeadm cluster admins. Oops, let me now do that. Let's look for the kubectl get describe service accounts. If any service accounts were being created, kubectl, let me just delete this. Yes. So we have a service account which is named as default. No secrets, no tokens as of now. Okay. Let's look for something interesting. So there is a backdoor shell with the privilege commands that is running on this machine. Okay. So now we are only left with our what we call it as the reverse shell detection. So let's look for this particular job. Describe let me first get ports. Backdoor shell. Let's look for the reverse shell. Sudo kubectl describe or reverse shell. Let's look what command was ran in the reverse shell. So the name of the particular for the pod is reverse shell, and it is running on the control plane directly. The date and the timing, what is the IP of the particular cluster. So it is running it, and this is the container ID, very very critical when you are creating a report. So what command it ran? It first install the netcat, then reversing persistently, then while true, it has run the traditional reverse shell command, which is bin/bash, and taking the reverse shell using the dev TCP directly on the attacker's machine. Okay. Now, similarly, let's look for, I think everything is being done. The only thing that remains is your seek token dot text file. Okay. So let's sorry, cat token dot txt. So this is my token. Let me look for it. Just give me a second once. So what I was doing is I just pasted the token on base 64. Now with the string, it looks like the JWT. So let's go for JWT.io and let's paste this token over there and let's see what is inside this particular token. Okay. So the token, the kit value is, you can actually go for claims or tables as well, but I like to go for the JSON. So in the JSON, it shows the odd which is running on the Kubernetes cluster, and it is running on the service HTTPS. The control plane, which is running on the attacker. The UID, the pod name is token stealer. This is the UID. Then it has the service account with the name default, and one after this. Now it is asking for the public key, or with which it is encrypted. You can just look for that public key if it is there, or you can just look for admin 123. Okay. So this is how we actually, perform our Kubernetes threat hunting when it comes, or Kubernetes forensics when it comes to a real type of environment. Now, for this lab, I have set it up only this, but when it comes to the real time scenarios, the log, because I have just given you the straightforward things, but when it comes to the real world scenario, the log analysis or the lab, it takes a lot of time, to analyze what is going on at the back end. So I hope you have liked my video. If you like my content, please do like, share, subscribe. I would really like to, it really gives me a boost. So, to create more stuff. My last video which I posted, I think it was uh, on the misconfiguration or the of the some AI engines to the GitHub that will leak the private repositories or the secrets from your own private repos. So do check it out. It is based on the prompt injection basically. But this is not the direct prompt injection which you are getting. This is the indirect prompt injection, which is based on when you are creating a small issue and the request is hidden inside that particular issue, and the AI engine, the AI bot is able to read the contents inside it, and it followed the instruction, and AI bot actually dumped the whole secrets to the attacker's environment. So do check it out. It is a very interesting video, and I have submitted certain bugs in the LLM application already, and some of the bugs are already submitted. This I accidentally found, and I have submitted the small vulnerability as well, which is based on the misconfiguration, and I'm expecting something out of it as well. Okay, so do check it out. And if you do like my videos, do like my content, please do like, share, and subscribe. It really gives me a boost. Do connect with me on LinkedIn, which is my linkedin.com/in slash, I think Dipanshu Khanna is the name, or you can just type Dipanshu Khanna on Google. You will get all information about me, which the information that only I want to do public. So nothing private information that I have kept it on as of now. So thank you everyone. Do enjoy your rest of the day or the weekend. I will upload the video maybe by Sunday. So do check it out. If you like it, please do like, share, and subscribe. Thank you everyone. I hope you have a great weekend.